I'm Mr. Carter, and this is math class. If any of you are wondering why I did that, ask Gennaro later. He knows. Inside joke. All right, so we're going to just do this first warm-up problem, and then we'll move on to quick notes, and then you can get your assignment from the substitute if you don't already have it. So warm-up is just a quick review of yesterday. So we need to condense these two logs on the left that are right here, and that way we can just ignore the logs because then we'll have one log equal to another log. So first step, two logs are being subtracted, so we can write them as one log being divided inside 2x minus 4 divided by 5. That should equal the log of 6. So now that the logs are the same on both sides, I can get rid of them, and we should just have 2x minus 4 divided by 5 equals 6. Then I can get rid of the divide 5 by multiplying both sides by 5, and 2x minus 4 equals 30. Add 4 to both sides, so 2x equals 34. And so divide by 2 to get x equals 17. Okay, so I erased all of that writing except for this little bit right here, which I'll get rid of. So we can look at three different types of log equations. So in part A, we have 3 to the x equals 15. Part B, log base 2 of 2x plus log base 2 of x equals log base 2 of negative 3x minus 1. And then in part C, we've got log base 2 of 4 plus log base 2 of 2x equals 4. So they're all a little bit different, and so I want to write down some of those differences now. Okay, so first thing we should definitely notice, there are no logs at all in that equation, and then we're going to actually introduce logs on both sides to solve. This is not new, we've done this before. So the first thing I do is just use the plain old log on the left side, so the log of 3 to the x equals the log of 15. Power rule lets us bring that x down and bring that down in front, so I get x times the log of 3 equals the log of 15. So since I'm multiplying by x, I want to divide both sides. I want to divide by the log of 3 on the left. And then what I do to one side, got to do to the other. So divide by log of 3 over here. And x equals log 15 over log of 3. And if you remember, I said that we can leave our answers like that. We don't have to get a decimal if we don't want. So on to the next one. Okay, so for part B, this log is exactly like the warm-up. So we have logs on both sides. We're going to condense and then remove those logs like we did yesterday and on the warm-up. So nothing really new here. Since I'm adding two logs together, I'm going to multiply their insides. So I end up with log base 2 of 2x squared, because 2x times x is 2x squared, equal to the log base 2 of negative 3x minus 1. So then I can drop the logs, since the bases match, and 2x squared equals negative 3x minus 1. Here's our big issue now. This is quadratic, so we have to bring everything to one side and set it equal to 0. So add 3x, add 1, add 3x, add 1. So I get 0 on the right, and I get 2x squared plus 3x plus 1 equals 0. So then we need to factor and solve. So I'm going to skip ahead for that. Okay, off to the right I did the little snowflake, whatever you want to call that thing, for factoring. And I got these two factors, 2x plus 1 and x plus 1 equals 0. So I have to set each of them equal to 0 and solve. So 2x plus 1 equals 0, x plus 1 equals 0. So x is negative 1 over here, and x is negative 1/2 over there. So actually a much nicer solution on this one, even though it required a little bit more work. So last one, part C. Okay, here's our last one, I promise. This is the weirdest one. This is brand new. So we have logs on one side equal to just a number. So that's kind of the big difference between the other two. We have not solved an equation like this, really. So what we're going to do is condense this left side. So the 4 and the 2x should get multiplied since the logs are being added. And then we're not going to be able to just drop the logs. We're going to have to rewrite this thing using the spiral trick we did a long time ago. And so you'll see me do that right now. So first we need to condense. So log base 2 of 4 times 2x is 8x equals just 4. So then spiral trick is that thing where I said, well, 2 to the 4th power is equal to 8x. So 2 to the 4th is equal to 8x. So now I don't have any logs in this equation. My exponent is basically solved for. I just need to simplify that 2 to the 4th power, which is 2 times 2 times 2 times 2, or 16, equals 8x. And now it's really, really, really easy to see that x is equal to 2 if I divide by 8 on both sides. So we're just going to jump to just a couple of quick more examples just to get you started, and then you can work on the homework. So I'm going to jump screens real quick. Okay, so last part of your notes, looking at numbers 1, 2, 3, and 4, we're just going to identify which kind of an equation are they similar to up above. So in number 1 here, we look and see there's logs on both sides of the equation, which is exactly like what we solved at first, so that would be similar to example A that we did up above, and we would make sure that the logs, there's only one on each side, and then we can drop them. So right away we find that n is equal to negative 3n, because we can drop both of those logs. And then to solve, I add 3n to both sides. So 4n equals 0, so naturally n has to equal 0. When I go over to number 2 here, oh, the ink is not moving with me. That's dumb. So I will just leave that in place. Okay. So number 2, that is similar to the last one we solved, or equation C, and we need to condense that into one logarithm, and then we can rewrite and solve. So I combine this as log base 3 of x divided by 9, because I've got to go first divided by second, is equal to 2. And then spiral trick says 3 raised to the second power is equal to x divided by 9. So then 3 squared we know is 9 equals x divided by 9. So then x has to be 81, because 81 divided by 9 is 9. Okay, number 3, the weirdest issue with number 3 is this multiply by 4 right here. That's out in front of that log, so I know a lot of you want to probably take and pull that up into the exponent, but it's going to cause us problems. So I want to get rid of that times 4 by dividing both sides by 4 first. So if I do that, I should just get the log base 2 of 2x minus 1 equals 3, because I divided that other side by 4. So then it is a log on one side, so it's very similar to part C from up above, and even number 2 that we just solved. So rewrite as an exponential, 2 to the 3rd power equals 2x minus 1. So 2 to the 3rd power is 8 equals 2x minus 1. Add 1 to both sides, so 9 equals 2x. And my answer would be a fraction, x equals 9 divided by 2. And again, you guys can pause these anytime you need to if I'm going too fast. So number 4 is similar to the second one we solved. That's the ones we spent a bunch of time on yesterday. I need to condense these two logs together. So we're going to multiply these two parts because I've got addition in between. So 3 times 2 is going to be 6. 3 times negative m is going to be negative 3m. And I still have the log on that. Equals the log of 15. So now I can drop the log, and 6 minus 3m equals 15. And if some of you are wondering, do I have to write that log in that second step, or excuse me, that first step every time? No. If you're getting good at this, go ahead and just skip that and just tell me that 6 minus 3m equals 15. I just urge I think you should be a little cautious with some of these because these are kind of new kinds of equations for you. So negative 3m equals, subtract 9 from both sides, so equals 9. And then m equals negative 3 if I divide both sides by negative 3. And that is done, I promise. So now your assignment, work on those problems from the worksheet that the sub left for you. If you get done before the day is over, just leave them with the sub, and he'll give them to me when I come back on Wednesday. So have fun.